Okay, so we're trying to add square roots. So notice what we're doing in 6.3, the section we just finished. We're in chapter 6 right now. We're learning all the rules for square roots, basically. So we just multiplied and divided and simplified a bunch of square roots. Now, 6.4, we're going to learn the rules for adding and subtracting radicals, they call them, roots, whatever you want to call them. 5 root 7 plus 9 root 7. How do you add root 7? Yeah. Just, you know what it is? It's like terms. It's like terms. You just add the 5 and the 9, 14, and you just keep the root 7. There we go. It's like terms. Like roots, if you want, you know. It's exactly like adding 5x and 9x, isn't it? You'd get 14x, except you have roots instead of x. And that's basically this whole section. If you'll just think the roots are exactly like the rules for letters, that'll work. It's exactly right. When it comes to adding, subtracting, that's the truth.
So what happens if we have to get a con?
So, okay, let me write it out here.
Two like terms.
So,
Root of 6 cancels out.
so 3 cube root of 4 minus square root of 6 plus 7 cube root of 4 plus square root of 6.
10 third root of 4.
All right, so combine the like terms up there. The root 6's just drop out, don't they? So what do we do with 3 cube root of 4 and 7 cube root of 4? 10 cube root of 4. It's just like terms again, isn't it? You just add, like terms means just add the numbers in the front. Don't mess with the roots.
This is too good to be true.
Is that good? Good for now? No trouble? So like terms again, just add the numbers in the front, don't mess with the roots. Okay, so cube root of 80. No, not cube root.
3.
That 3 is in the front, not in the hook. That's an important difference, huh?
3 squared.
That 3 is just in the front, and that 2, they're not in the hook. So what's really in the hooks then? Both hooks have nothing, which means 2. Yeah. So go ahead and just break down that 80 and break down that 125. It's just a 2-for-1 deal. Just, do that. I'm going to move it. I have more room. So it's 3 root 80 plus 2 root 125. So break them down. 80 is 8 times 10. 2 times 4. 2 times 5. 2.
Okay.
Good. And so remember that this is a 2-for-1 deal.
34 cubic.
Try that and then break down the other one. Give you a second, see if you can get that. Okay. And then so this is a 2 2's here, 2 2's there. So that's going to send out a 2. That's going to send out a 2. What's left on the inside? 5. So 2 times 2, so 2 times 2 times 3, it's 4 times 3. 12 on the outside, 5 left on the inside. Good for that first one? How are we doing? So what happened on that first one when I broke it down? Right? So on the outside, 2 times 2 is 4 times 3 is 12. And there's a 5 left over inside. Good? Now, the 125. What times what's 125? You know it divides by 5, right? Because it ends with a 5. So use your calculator. Divide by 5. 5 times 25. Keep going. 5 times 5. All right. So what do we?
3, 5.
So 2 5s on the inside. It's a 2 for 1 deal, right? 2 5s on the inside sends 1 5 to the outside, which is going to multiply that 2 that's already out there, right? When you send stuff to the front of a root and there's already numbers out there, they multiply. So 2 times 5 is 10. What's left in the root? This leftover 5. We good to there so far? It's all the 2 for 1 stuff. Now, can we add these guys? Yeah, they're like roots. Now, if the roots were different, let me mention, if this was like root 6, if it was like 12 root 5 and 10 root 6, you can't add them. That would be done. Just stop right there. They would be unlike roots. Different root numbers are like different letters. That'd be like 10x and 12y or something. You can't add them. But if they're the same numbers in the roots, which these are like roots, what do? You add the numbers in the front. 12 roots of 5 and 10 roots of 5 is 22 roots of 5. Like that. Good? Let's just all these 2 for 1 rules and then like terms. So number 6. So square root of 2a plus 2 square root of 18a to the third. All right. So you got to break that 18a to the third down, don't you? Break that down. Do the 2 for 1 deal. Right? There's nothing in the hook, so it's 2. 2 for 1 deal on the 18a to the third.
Everything's
So break that 18 down. 2 times 9, 3 times 3. A cubed is A. Or you can just divide that power by 2 if you want. But there's 2 in the hook, divide by 2. But when there's only 3 of them, I'm just going to write them out. So 2 3's in. 1 3 out. 2 A's in. 1 A out. Am I going too quick? You good? So what do we have? Root of 2a. What makes it out? 3 times 2, 6a. What's left inside? 2 and a. How we doing? Is that good so far? It's making sense? Everybody okay with that? I broke down that 18a cubed. So I broke down the 18a to the third. 2 times 9, 9 is 3 times 3, 2 3's in, 1 3 out, 2 a's in, 1 a out. So out comes 3 times 2 times a, 6a. See how I got that? Because that stuff all came out. And what's left inside? Leftover 2, leftover a. Okay, now, can I add these guys? Not quite. They're the same root, but this one also has an a in the front. He doesn't. So their letter patterns are not quite identical. Part of their letter pattern is different. Because that's what like terms mean. Like terms have the same letter and root patterns identical, and they just have different numbers in the front. But their letter and root patterns are the same. Not quite. This is an a root of 2a, and this is just a root of 2a. So they're not like terms. So you cannot add them. So what do we do then? You know what you can do, though? Because they're partly alike, aren't they? The root parts are the same, even though they're not entirely the same. What could you do? You could factor. Factor out the part that's the same, root 2a. So I can take the root 2a, since they both have a root 2a, don't they? They both have a root 2a. What does that leave on the inside? Root 2a times what? We'll go back to root 2a.
1.
1. And root 2a times what? We'll go back to 6a root 2a. 6a, we're done. Does that make sense what happened there? So they were not completely like terms. So I couldn't add them. I could not add them. They were not totally like terms. This was the first one's root 2a, the second one's a root 2a. It's a little bit different. It's not like terms. So I factored out the root 2a common piece. Because I could not add them as like terms. Are we doing good? Like I'm just pouring on the root rules real fast here. So it's just this. That is it. That's as combined as we can make it. We cannot combine it any more than that.
Could you just leave it?
No, they do want you to factor out the common part. Yeah. All right. Okay, so break those down. 9 cube root of 13. Yeah, so just got a bunch of factoring to do. So it's 9 cube root of 32 minus cube root of 108 plus 8 cube root of 500.
And one of them doesn't have numbers in it, or does it have -1?
So break down that 32. Break down that 108. Use your calculator. The 500 on the end, that's 5 times 100, and 100 is 10 times 10. Right? Break that down. So break them all down and do the, it's a what? 3 in the hook, so 3 for 1 ship out? 3 for 1 deal? Times 8. You good to there? So it's a 3 shipper, so 3 2s in. It's easy to miss an extra 2 or something. Be careful. Sends a 2 out. 18. You get 18 cube root of 4 for the first one? 18 cube root of 4 on the first one. Right, these 2 2s. Leave a 4. The middle one. Oh no, wait, what's that? 2 times 54. 6 times 9. 2 times 3. 3 times 3. So that's a 3 shipper. 3 for 1. So 3 3s in. 1 3 out. 2 extra 2s in. Leaves cube root of 4, doesn't it? So the middle one is 3 cube root of 4. Did you get that?
So, is this, do you never want to subtract here, or do you always?
We'll get them all. First, let's first get them all. It's okay, you could, but I'm just going to finish them first. And now the 500, 5 times 100, 10 times 10, 5 times 2, 5 times 2. Okay, what does that mean? Well, looks like we got, I'll bring this 5 down here. Looks like we got 1, 2, 3, 5. Yeah, it might help if you bring everything down to the bottom line. Maybe I should have been doing that all along. Like bring these 2's down, you know. 2, 2, 2. That way you can see them all together. You know, if that helps. So, whatever. So 3 5's in, 1 5 out. Now there's already an 8 out there. Right? This is the 8 that's been there all along. That's in addition to the 5 that comes out. And what's left on the inside? Cube root of 4 again. 2 2's. Is that good to there? Now what is 5 times 8?
40.
40. I should probably just... Yeah, I should do it this way. It's 40. It's going to be 40. 3 5's. 5 times 8 right there produces that to be 40. Okay, right? So the 5 times 8 multiplies to be 40. So 18 cube roots of 4 minus 3 cube roots of 4. What's that? 15? Plus 40 is 55 cube roots of 4. They're all like terms, aren't they? They're all cube roots of 4. That's tedious. There's a long section of 2 for 1 and all that. 3 for 1 in this case. Is that good? We okay?
Yeah, factor them here.
Yeah, right. So we got to factor that. Square root of 9y minus 45 plus the square root of y minus 5. Yeah, can you factor that 9y minus 45?
Yeah.
Take out a 9, like that. And then what can I do with the square root of 9? What's the square root of 9?
3.
3. Out comes a 3. Really, because 9 has got 2 3's and 2 in, 1 out. Right? So 3 comes out. We good to there? Right? Square root of 9 is 3. Or you could say, look, 9 is 2 3's in, 1 3 out. However you want to say it. Can you finish it from there?
Because you have 2y minus 5's and the roots. Don't they like turn into 1?
I'll talk about that in a second.
Okay.
So what we do here? What's the answer? Am I losing you? How are we doing? We're an hour and a half into math here. So we have 3 roots of y minus 1. And really 1 more root of y minus 1.
Y minus 5.
It's 4 roots
Y
of
minus 5.
y minus 5. Sorry, I'm missing the wrong thing. Yeah. So it's 3 roots of y minus 5 and 1 more root of y minus 5. It's 4 roots of y minus 5. Like terms. Now, a good question was asked. What about, don't we like, when you have 2 roots of y minus 5, isn't it like 2 in, 1 out? Why isn't it like a regular y minus 5? Because these are not multiplied. These are added. So that's a good question. And that's what's hard in math, isn't it? Let me stop for a second and just say a word about learning math, which you're all wanting to do, and so you can get done with these math requirements and get on with your life. Big part of learning math is to learn the categories. You know what I mean? You ever looked at a math test and said, man, they all look alike? You know, when you get the test in your hand, you did all the homework, but you get the test in your hand, you're like, they all look alike. How is this the one where you do this? Right. I mean, so know that. That's a typical problem. I've experienced that. That's part of the battle. That's exactly it. And you want to be really intentional with, categorizing the problems as you go. So you want to look at this and go, this is adding, subtracting. So on the test, it won't say, this is adding, subtracting, but you'll see the plus sign. So, okay, this is adding, which means what? We're doing like terms. We're looking for like terms. That's the kind of thinking you should have in your mind. Whereas if it was root of y minus 5 times, there's a minus there, root of y minus 5, that's not like terms, that's multiplied. That's the 2 for 1. You'd say there's 2y minus 5's in, there's 1y minus 5 out. That would be if they were times. But if they're added, subtracted, we're not thinking about that. We're thinking like terms. 3 roots of y minus 5, and one more is 4. Was there a question, Abraham?
Yeah, on number 5, when you had to factor out the square root 2a and
Right.
the plus the 6a square root 2a.
5? Did I do 5?
That was 6.
6? Okay, 6. Go ahead, I'm sorry.
Yeah.
What about it?
Just because it has an a up front, it's different than.
Yes,
number 9?
that's exactly the problem. This A right here up front makes it unlike, because this is an A rooted. If there's anything different in the letter pattern, then it's unlike. And that A up front makes the letter pattern different. Exactly right.
If it would have just been 6, would you have just added it? Like that?
Yes.
The whole one?
Exactly. Good job, guys. Because there's a 1 here. If it just had the 6 and no A, we'd just add it up, be 7 roots of 2A. That would have been exactly right. Good, you're dialing in. Is everybody catching that? But because the A was there, I'm jumping back to number 6. Because the A was there, that made it a different letter pattern, unlike. So we cannot add them. Because it's not 7A root 2A. This one doesn't have an A. It's like, I don't got an A. They're not like. Yeah, good. We all getting this? So categorize. You want in math. So remember, we're in the adding, subtracting section. So that's like terms. You want to think about like terms. All right, so we have the root of 11 times 2 minus 9 root 11. Now we're multiplying and adding, subtracting. Now they're going to mix them on us, which is good, because that's how the real exam is. So you want to practice that. That's why I give those practice exams, because you can do the homework, but it's the same thing 10 times in a row or 20 times in a row. Whereas the practice test mixes it all up like a real test. All right, so here we go. I'm going to multiply. Yeah, I'm going to distribute. This is going to go here, and this is going to go there. But there's an important rule when we distribute. Outside stuff stays outside. Inside stuff stays inside. And there's no crossing the line. So in other words, when root 11 hits the 2, they're not going to make 22. Why? Because the 2 is going to stay outside the root, and the 11 is going to stay inside the root. Good so far? So it's like, the perfect analogy is prison. There's no crossing the line. All right? I don't mean to make light of a sad situation, but it works perfect for our little problems here. Outsiders are outsiders, and insiders are insiders, and you can't cross the line, right? So that's how it is with the roots. So insider stays insider, the 2 stays outside. Now, what happens when the root 11 hits the 9 root 11? Same kind of thing. The 9's an outsider, and the 2 11's go together inside. Now, rather than multiplying 11, get whatever it is, 121, I'd rather say, look, what can I do with 2 11's in a root?
One goes outside.
Yeah, 2 in, 1 out, right? There's nothing in the hook here. It's a 2 for 1 deal. 2 11's in, 1 11 out. So I guess that's how you get out of the jail. You got to have 2. 2 in, 1 out. I guess my analogy breaks down there. So and then they're gone, right? The 2 in, 1 out. The 11's are gone. So 2 root 11 minus. Now that 9 and 11 can multiply, because now the 1 11 that came out is an outsider. 9 times 11, 99, done. Did you track with that? So when you multiply, outsiders with outsiders, insiders with insiders.
And because the 99 is not rooted in 11, it can't multiply with the 2? Because it's not root 11, it cannot multiply with that 2.
Right, yeah, these guys cannot multiply because they're 11's an insider, the 2's an outsider, right. And then the 2 11's inside sent 1 11 outside. And for now on, can we take a shortcut, guys, just to speed things up? So root 11 times root 11, do you realize that's always going to be plain 11? Because there's 2 inside. So it'll lead to 1 outside. So I think you will enjoy going a little quicker in your homework. Anytime root 11 hits another root 11, you just say plain 11. 2 in, 1 out. 2 11s in, 1 out. So, okay, let's make sure we're making sense. What's root 17, root 17? Plain 17. What's root 97, root 97?
97.
Plain 97. Now I'm going to try to trick you. You ready? You feeling sharp, right? Think, how can you trick me? Probably can't, but let's try it. Root 9, root 9.
9.
Uh-oh. Is there some uncertainty setting in?
No, 9.
Am I rocking your confidence?
Is it multiplying?
Is it 9 or 3?
3 times 3 times 3 times 3, so it's 3 times 3 is 9.
You know, I think if I just say it loud and clear, it seems funny to say that would help. But I really think it will. Because you'll hear the pattern a little stronger. Right. Root 17, root 17, 17. Root 97, root 97, 97. Root 9, root 9.
9.
Yes, 9. See, it helps. Not 3. The root's done. Yeah, but the root of 9 is 3. Yeah, but the root is gone now. There's no more root on that 9. He is gone. But I've seen it in the past where people make it 3, so I wanted to be clear with you. I've seen it confuse people in the past. Remember, the 2 9s in is 1 9 out. He's not in anymore. It's not a root of 9 anymore. So it's not 3. It's 9. Good?
Okay.
We all good with that? All right. So
even
there we go.
Even if you break it down, it ends up being.
Yeah, right. You can. Was that it? Let me flash back. Let's see. It was 2 root 11 minus 99. Exactly. That was the final answer. All right. Let's try this one. Let's take that root 2 times negative 6 root 2 plus 9. So let that root 2 on the outside distribute in, but remember the rule: outsiders with outsiders, insiders with insiders.
But does it hit everything individually?
It'll hit each term. There's 2 terms. Yeah, good question. The terms are separated by pluses and minuses. So the root 2 will hit the whole minus 6 root 2 term, and then he'll go to the 9. So what happens when the root 2 on the outside multiplies the negative 6 root 2? Yeah, the 2 2's on the inside, they get together. The 6 is just sitting on the outside. He's not doing anything. The negative 6. Right? He's just sitting there. But the 2 2's on the inside, what's root 2 root 2?
Plain 2.
Plain 2. That's going to become a negative 12, huh?
Yeah.
You good to there so far? See how the 2 root 2's, the 2 2's inside made 1 2 outside. I mean, you can make it root 4, and then that is plain 2. You see, same rule. And then root 2 times 9, so I can make root 18? Nope, the 9 stays outside, the 2 stays inside. Is that good? And that's minus 12 plus 9 root 2. We're done. Okay, I cannot add those or subtract them because they're unlike. Remember the rules for adding, subtracting? They're unlike terms or roots. So I'm done right there. If this was a 12 root 2 or a negative 12 root 2 plus 9, yeah, then I would subtract them and get negative 3 root 2. If they both had roots, same like roots, but they don't. It's just like minus 12 plus 9x or something. They're unlike, huh? Is that good on that one? Outsiders with outsiders, insiders with insiders. Yeah, exactly. So I guess I better do it if you have to, huh? So cube root of 3 times cube root of 9 minus 6 cube root of 243. All right, multiply it out. Outsiders with outsiders, insiders with insiders. So this guy's going boom and boom. So use your calculator, big numbers here. 20 cube root of 27. So far so good. Minus 6 cube root of, what's that, 729? Is that good so far? Big awful numbers. How we doing? Just good. Now, how do we break down that 27?
It's cube root
3 times 9, 3 times 3. Is okay to there, so 3 3's in, 1 3 out. No more root for the first one. Okay, what about the 729? 3 times, just use your calculator. Take 729, you know 3 goes in. So divide by 3. 3 times 2, 43. Divide by 3 again, 81. And that's 9 times 9, 3, 3, 3, 3. Bunch of 3s. Bring these guys down. Have them all on the same level. How are we doing? Am I racing ahead of you? You okay? Let me see what happened. The insiders multiplied, then I broke down the 729. It's 6 3s. You know the deal. 3 for 1 deal. So 3 3s in, 1 3 out, 3 3s in, 1 3 out. And they multiply with the negative 6 that's already out there. Don't they? Easy to forget about that 6 out there. Good to there. So it's 3. We bring it. Well, I don't know where to put it. I'm running out of room. It's a long problem. So it's 3 minus whatever that is. 36? No, 54?
54.
Yeah. Which is negative 51. It's just a nice clean whole number in the end. No roots left. Is that okay? They're messy, aren't they? All right, everybody okay with that breakdown of that big ugly 729? 6 3s, and then a 3 and a 3 come out with the 6 already out there, 54. Subtract them, negative 51. All right. So there it is. Okay, so root of 8 minus root 5 times root 8 plus root 5. All right, so just a FOIL. Just go ahead and FOIL. And remember, 2 of the same thing. Like, what's root 8 going to be?
8.
Plain 8, right? 2 8's in the root, 1 8 out.
Are we gonna have to factor it and set everything equal to 0?
Right? Root 8. Plain 8, right? 2 8's in, 1 8 out for the first one.
Something's gonna drop out. The middle's gonna drop out.
Plus root 40. He's done. Good so far. Let's let that root 8 go to both. Remember, when they're 2 of the same inside sends 1 out, right? That's how you make the jailbreak. Got to have a twin. Then they don't know which one you are. No, I'm sorry. I'm just doing goofy analogies. Maybe that'll help you remember, though. It's got to be twins. It's got to be 2 of the same that gets out of the root, right? And then boom and a boom. Minus root 40. And minus root 5,
5.
plain 5. There's the twins making the jailbreak. Right? Good so far? So what does that equal? Just cancel. It's a minus 5 back there, right?
Just getting it out of them.
8 minus 5 is 3. Look at that. Just all simplified down to be plain 3.
All that.
Is that okay? Tracking with these rules? So the twins, 2 of the same thing in a root. Root 8 is plain 8. Root 5, plain 5. Okay, so 7 plus root 2, 7 minus root 2. Try that. Foil it out. Remember the rule, outside stuff with outside, inside stuff with inside. So boom, boom.
I know.
How are we doing? 7 times 7?
49.
That's just plain 49. No roots there or anything fancy. Just 7 times 7. And then 7 times negative root 2. Negative 7 root 2. The outside 7 stays outside. The 2 stays inside. He's done. And now, this guy goes to both. Plus 7 root 2. Good. 7 stays outside. 2 stays inside. And now, here's for the last one. You good? Positive root 2 times negative root 2. Positive times negative is negative. Root 2, plain 2. Right? 2 2's in, the twins jailbreak, 1 2 out. These cancel in the middle, don't they?
So 49 minus 47.
So it's all 49 minus 2? It's 47. Is that good? All right, I'm going to keep going. Root 10 plus 1, 3 root 10 plus 1. So FOIL that out. Can you FOIL that? So remember, outsiders with outsiders, insiders with insiders.
So that would be 30 times 10. Root 10 is 10. 10 times 2.
You should get 31 plus 4 root 10 in the end.
That's the answer.
You can get that.
Yeah. 31 plus 4 over 10.
See if you can get that. Make sure you can get that answer on your own papers. So I'm going to take this root 10 and go boom, boom. What happens when root 10 multiplies 3 root 10? The root 10 part make 1 out. Plain 10, don't they? So it's 3 times plain 10 is going to be 30. You can just make it 30 right away if you want. I'm just showing it more slowly. It's 30, right? Because the root 10, plain 10 times the 3. It's all multiplying, right? Plus, root 10 times 1 is root 10.
Well, 1 root 10.
1 root 10 if you want. And then this is going to multiply. 3 root 10 plus 1 times 1 is 1. Good? So far. Now, these two in the middle are like terms. They're both the same root. Now we're adding. Now we go into a different mode. That's the trick on this. You got to be able to shift modes. Now we're adding mode, right? So it's 1 root 10 and 3 root 10. It's 4 root 10. We're adding. We're not saying 2 root 10s make a regular 10. No. That's for multiplying, isn't it? Everybody catching that difference? If you're multiplying 2 of the same roots, yeah, that sends 1 out as a plain 10, right? If it's root 10 times root 10. But when you're adding a couple root 10s, you just add the numbers in the front. It's just like roots. Different rules for adding, subtracting versus multiplying, huh? Plus 1, 30 and 1, 31. Plus 4 root 10. There it is. Now, I cannot add those and make 35, can I? Because those are unlike. One of them's got a root, one of them doesn't. Is that good? Good? Questions on that? Yeah. 30 in the what's that? In the front? 30 in the front? Yeah, so the root 10, good question. I'm sure a lot of other people wonder the same thing. Root 10, yeah, makes a plain 10. Yeah, 2 10s in the root, right? That's the twins make the jailbreak. So the 10 and the 10 makes the plain 10, and then the 3's there also, 3 times 10, 30. Yeah, good question. Is everybody tracking with that now? Is that making sense? All right. We're falling rapidly behind. All right, so try that one. 7 plus root
It would
6.
boost our morale if you let us out early. And we would do better on this.
So what do you do with that 2 power?
Write it twice.
2 parentheses, right? We got to write 2 of those. Two of them. Isn't it 54 plus 14 root 6? See if you can get that. So boom, boom, right? So we start foiling out here. So 7 times 7, 49. Plus 7 root 6. That 7 is an outsider. He stays outside. 6 stays inside. He's done. Good so far. And then the root 6 goes to both. 7 root 6. And root 6, root 6? Plain 6. Everybody good with that last? Plain 6. Twins make the jailbreak. 2 of the same roots. Okay, it's 55, huh? I messed up, yeah. 49 and 6 is 55, that's right. And then 7 root 6 and 7 root 6, 14 root 6. And they can't combine any further, huh? Because one of them's got a root, the other doesn't. It's on like terms. There it is. Yeah, it's 55, not 54. Good. He's getting easy. Our last